Hello there, physics students. In this video, what we're going to do is we're going to write a vector program. It is second semester, and we learned how to add vectors back in first semester. So back in first semester, we learned how to decompose a vector and then add the vector component-wise and then recompose. And we use these four formulas. So we use these two formulas to decompose the vector, and we use these two formulas to compose a vector. So this is what's going to be popping up in our program. So when we're done with our program, if we add these two vectors, this 3 newtons at an angle of 0 degrees and 4 newtons at an angle of 90 degrees, well, that's just a 3, 4, 5 triangle. We should be able to get 5 newtons at an angle of 53 degrees. Okay, let's get started then. Very first thing you want to do is hit Program, and you want to go to New. Okay, and create new, and we're going to name this Vector. And just remember that you are already in alpha lock mode, so you just type Vector. Hit Enter, and now we are programming. The very first thing I like to do in all of my programs is to clear the home screen. So I'm going to hit the Program key, and then I'm going to go to I/O, and number 8 is clear home. I always want to make sure that I'm in degree mode when I am adding vectors. So I'm going to hit my mode key, and I'm going to go down and I'm going to select degree. Hit enter and enter again. The next thing we want to do is we want to clear list L1 and L2 because that's where we're going to put our table. So I've chosen clear list, and I'll show where I got that in just a second. So I want to do second and then L1, and then to get clear list, I go to stat, and number 4 is clear list, and then L2. So second, and then the number 2. All right, the next thing we want to do in this program is we want to ask the user of our program how many vectors they're going to add. So I go to Program, I go to Input and Output, I/O, and I want to do a prompt. I'm sorry, a display. And I'm just going to put how many. So I'm going to do alpha lock, and then I'm going to start typing. Now, anything we type that we put in quotes will show up on the screen exactly as we type it. The space is the 0. Okay, so I'm asking how many. Now I have to get this response from the user, so I'm going to go to Program. I'm going to go to I/O. I/O stands for Input and Output, and I'm going to prompt, and now I have to give it a variable. So I'm going to give it the variable n, so alpha n. So what's going to happen is the user is going to put in a number, and that number is going to get stored into the variable n. So I've temporarily quit the editing. You don't have to do this, but just to show you what's going on so far. So I go to Program, I go to number 6, which is Vector, and I hit Enter, and it's asking me how many, and I'm going to say we're going to add 3 vectors, and that's it, okay? Now if I go to alpha n, you can see that n has the number 3 stored in it. Now what I need to do is to repeat the code a couple of times now, n times. So I have to repeat the code where we prompt the user to enter the magnitude and direction of the first vector, and then the magnitude and direction of the second vector, the third vector, and so forth. And the way we do a loop in programming is, well, we can do it a couple of different ways. We can use what's called a for loop, or we can use a while loop. I'm going to use a for loop. So I'm going to go to Program, Control, you can see the keyword for, and it's number 4. They're very clever, aren't they? Okay, so, and the for loop looks like this. So for I is what's called the index variable. So I will be 1. Okay, I will be 1 because I put a 1 here. And we're going to do this loop n times. So I is going to be 1, then 2, then 3. And then once I gets to be the same value of n, then the loop stops. And this 1 means the increment. How are we going to go up? We're going to start I at 1. We're going to go up by 1. Okay, we could start I at 0 and go up by tens. So it's a very flexible way to repeat a chunk of code. So in this code, I want to ask the user for the first vector. So I'm going to go to Program, I'm going to go to IO, and I'm going to display, and then I'm going to go alpha lock. Okay, so I'm going to display mag, okay, and then I'm going to get out of alpha lock by hitting the alpha key again, and then I'm going to do comma, right, and then alpha n. Okay, so if we put the comma n here, then it will display, whoops, should be comma I. It will display the current value of I. So with this for loop, if n is 3, I will be 1, then 2, then 3. And so that'll just remind the user which magnitude that they're entering. Because they might get confused if they have a whole bunch of vectors, which one that they, oh, did I just enter this one or did I not? Okay, now we need to read in the magnitude, and I think, how about we read that into the variable m? So we're going to go program, IO, to alpha, m. How about the variable m? We have the mass of Earth stored in there, so it gets a little confusing. We're running out of variables. And now we're going to do the same thing to get the angle theta. Again, after I type angle, I'm going to close quote. I'm going to hit alpha, comma, and then I want to put this into a variable. And how about theta? Okay, so if you do alpha 3, that gives us theta. Oops, sorry, I made another mistake. That should be an I again. Okay, so this is the ith angle that they're going to input here. So alpha I. Now we're going to do prompt theta. So program IO to alpha theta. Okay, hit enter. Okay, so what I'm going to do, and you don't have to do this now, but what I'm going to do is I'm going to end this. So I'm going to go to program, and I'm going to do number 7, and that will end the for loop. And then I'm going to quit, and we're going to run this program. So program 6, run the program. How many vectors? One with 3 vectors. The first one is going to be 3 at an angle of 0. The next one's going to be 4 at an angle of 30 degrees. And the next one's going to be 5 at an angle of 90 degrees. If you kind of look how this is scrolling, I don't like that scrolling look. I wish it would just maybe clear the screen and let us enter a vector at a time. And we can do that. We can add that functionality. Right? But this is what's happening so far. So what's not happening is we're not decomposing the vector as we get it. Okay? So as soon as we get a vector, we need to decompose it and put it into a table form. Okay? And the nicest place is in the stat, okay, into L1 and L2. So we're going to do those two things when we go back. Okay, the first thing we want to do is we want to clear the home screen every time we go through the for loop. So with your cursor sitting right on this D, if you go to second, insert, and you hit enter, that will insert a blank line. Go back up with your cursor on that blank line, go to program, then go to IO, and then 8, clear home. So that'll clear the home screen every time we go through this for loop. Right? And then the next thing we want to do is we want to store this into L1 and L2. We want the X component in L1 and we want the Y component in L2. So to decompose the vector, we want to take the magnitude times the cosine of theta, cosine of theta, and then we want to store that. Remember, store is above the on key. We want to store this into L1. So we do second L1, but where in L1? Okay, remember we're looping through this. We want the first row of L1 to have our first vector, the second row of L1 to have the second vector, and so forth. Okay, and I keeps track of, the variable I keeps track of what row we're in. And so that's what I'm going to do. I'm going to do L1 alpha I in parentheses. So this says L1 into the ith row. Okay? And we're going to do the same thing with the cosine for the y component. Oops. Should be second L2 parentheses alpha I close parentheses. All right, and let's go ahead and end this for loop. Okay, number 7. There we go. And now when I quit and I run this program again, you can see it's a little bit cleaner. So how many? 3. All right. So magnitude of 3 and an angle of 0 degrees. And see how it cleared the screen now? This is the magnitude of the second vector. The magnitude of the second vector, I don't know, is 4 at an angle of 30 degrees. It'll clear it again, and then a magnitude of 5 at an angle of 90 degrees. Okay, and that should be the end of the program. Now, if everything is working properly, we should be able to go into stat, and we should be able to see, if we go to edit and we look at the editor, we can see our decomposed vectors are here. Okay, the first vector was 3 at an angle of 0. That's all in the x, none in the y. Okay, so now we have our decomposed vectors into L1 and L2. As you're programming, if you end up in a weird space here like this, if you could just end up at the home screen again, just go back to program, go to edit, and then go back to the program that you were editing here, which is number 6. Okay, so now that we have L1 and L2, we have our x components in L1 and our y components in L2, now we need to sum them. All right, in order to sum them, we're going to go to we're going to go to list, so second stat, we're going to go to math, and sum. So number 5, sum L1, store, and then let's put this into x. How about alpha x? Okay, and then we're going to do the same thing with L2. Okay, so now we have summed all the x components. We put those in x. We summed the y components. We have those in y. Now we need to compose the vector. So in order to compose the vector, we could do square root, we do x squared, so alpha x squared plus alpha y squared, close parentheses, and let's go ahead and store that back into m. Let's use m for magnitude, so alpha m. So we have the magnitude of the sum of these, and now we have to get the angle theta. In order to get the angle theta, we do second tan, so second tangent, and we do the y divided by the x, so alpha y divide alpha x, like so. And then we're going to store this into theta. So store alpha theta, like so. Okay, we have one more piece to worry about, and that's adding 180 degrees to the angle. So we add 180 degrees if the x component is negative. So if this x value right here is negative, then we have to add 180. So the way that we do this is we go to program, we go, very first thing under control is if. So if, I like to use parentheses, if x is negative, so alpha x is negative. Now to get the less than sign, we want test. So we're going to do second math, and there's number 5 is less than 0, close parentheses. Okay. Now for the if statement has a companion. It's called then. So if, number 2, then take whatever's stored in theta, so alpha theta, add 180, and store back into theta, like so. Okay? And then we want to end this if statement, so we're going to do end. So go back to program. Number 7 is end, like so. So that's it. Now we're ready to display our results. So in order to display the results, we go to program, we go to I/O, we do display, and then we're going to do an alpha lock. Okay? And then I'm going to type magnitude equals, and then do an output of that. Okay, and then we want to hit alpha, and then comma, and then alpha m to display the magnitude. And we're going to do the same thing with theta. Okay, and there is our complete vector addition program. Okay, so when we run it, if I add two vectors, one at 3 has a magnitude of 3 at an angle of 0. Another one has a magnitude of 4 at an angle of 90 degrees. We should get a magnitude of 5. Oh, did I say 3? Oopsie. Here, let me try that again. So I'm going to run the program. How many? 2 vectors. Okay, the first one has a magnitude of 3 at an angle of 0 degrees. The next one has a magnitude of 5 at an angle of 90 degrees. Okay. We should get a magnitude of 5. So it should be 3, 4, 5. Okay, so you should get a magnitude of 5 and an angle of 53 degrees. Again, that's if you use 3 at 0 degrees, 4 at 90 degrees.